Software Academy collaborated with a tech giant HP in order for our capstone project, in order to discover how neural processing units are shaping the future for the local AI on Z by HP Mobile's Workstations. In our presentation, we will present our approach of our project and how we benchmark the NPU against the CPU and GPU, as well as running a small large language model locally. And next we will give a live demo, and in the final we will present the current challenges on NPU adoption. Let's introduce my team, our team. Jan, with a background in neuroscience and movement science. Christina, coming from biomedical imaging. Lisa, with a background in science, social science, and myself in banking and statistics field. As we know, HP is providing AI technology by enabling productivity, security, and environmental responsibility. The development of AI PC is driven by increasing the demand for AI and local AI capabilities in various applications that enable AI workflow, optimize the three-dimensional modeling, and the machine learning development. As AI technology advances, these computers will continue to evolve and will become more powerfully and more for our experiences as neural processing unit for Copilot PC and AI workstations. In our project, we will focus to create a tool to showcase what an AI workstation is capable of. And after we will compare the performance of different processors, and we will show real-life use cases for AI tools. And the question of our project was, why an HP AI workstation? If we compare with standard PC, the HP AI PC workstation offers specifically a powerful hardware to run AI tools, to optimize the AI usage, and also it contains neural processing unit. And all the concept will be presented by Jan.
Thanks a lot, Natalia. So we had this question, why HP AI workstation? And to approach this project, there were lots of things we had to do, lots of challenges that we needed to face to then come to this final project of having a dashboard to show this. I mean, this picture kind of shows you, of course, we're showing the tip of the iceberg, but there's lots of stuff going around in the background that we had to tackle. So what were the things that we needed to do? So first, of course, we need to implement locally. So running on a local device is not trivial because we have to take the specification of the device in mind and also have to run the model on this device. Then, of course, we need to leverage the capabilities this workstation gives us. And this is what we've done by using the state-of-the-art AI tools that are used in real life and that you may or may have encountered already. And lastly, of course, producing this tip of the iceberg, showing this dashboard to show this performance. So starting with the first thing, why even implement locally? So, I mean, cloud computing is what's used most commonly, but there's some skepticism around, especially with privacy. Some people are comfortable to upload sensitive documents into the cloud. So this is why we can use local computing. Sometimes you need to be on the premise with your laptop to run these models, because maybe you even need this reduced latency, so producing a high performance application. So this leads to some use cases. For example, local PC have offline accessibility. You can handle sensitive documents. You can customize it to your needs. And depending on the company or country, it has compliance with the regulation or can fulfill compliance with regulation. Then moving on to the second part is to leverage this AI workstation. So how do we do it? I think the biggest novelty of this AI workstation is this NPU. NPU is short for Neural Processing Unit. And you can think of it like a CPU or GPU, but optimized for AI usage. And its main advantages is efficiency, while also having a reasonable speed. And this is what we want to use to test execution time and also to test resource usage with current AI tools to showcase what the NPU is capable of, and also the workstation in general. And this leads then for use cases where we can think of using an AI workstation, which is, for example, you have constantly AI workflows running, and then you can offload some of these tasks to the NPU. So you can use your CPU or GPU for other tasks and save energy. And this brings us also to where it is applied. So edge computing I already mentioned, so being on the premise, being on the site itself, but also in natural language processing or computer vision when you think of self-driving cars, for example. So what AI tools did we actually use then? So of course, you already encountered an AI chatbot, I guess, on a web page. This is what we implemented in our dashboard as well to cover this topic of natural language processing. Also, computer vision is a really important topic in robotics, for example, self-driving cars already mentioned, where you want to have a fast-running PC to use, for example, object detection task. And this is what you can see on the picture. This is what an object detection model can give you. You have a picture, and then it draws the boxes around each of the elements it finds and labels them. And this can even be applied in videos. So yeah, use cases are, apart from the AI chatbot, also traffic control. Also in healthcare, you can use image classification, and so on. There are probably so many more use cases. Okay, moving on now to quick summary, what we done for our approach. So we covered in our dashboard natural language processing by implementing this chatbot. We're using Retrieval Augmented Generation technique, which gives the chatbot access to internal documents and can provide an answer based on these documents. We use computer vision to leverage the capabilities of the NPU and to benchmark these and to show how it performs. And lastly, all is done locally on 2 different workstations, where we compare a more powerful to a less powerful one, or one device to the other. And this brings us now to the live demo that Marisa will present this.
Thank you. So I'll walk you through the app that we developed. So for today, it's going to be just a video, but this app is supported on both devices, the ZBook Power and the ZBook Firefly, that are going to be in the showroom in Geneva for people to have real experience on it. So first we have the chatbot. You get a lot of text explaining what it is, why we run locally, everything Jan explained. And at the bottom, if you're interested in how we implemented and what we did under the hood, you can also have this information. And to use this chatbot, all you need to do is to click on the right button down there, and you can start typing any question that you have. So for today, for example, what is an NPU? And when we submit, it will start running and try to retrieve the answer. Again, this is running locally. So it's retrieving the information from documents that we preloaded into the machine, and you can really cater that to your user. So it's taking a little bit of time, but you can also see here on the right side what is happening, how the CPUs and the GPUs are being used, and here you have your answer. The other task that we implemented was image detection. So here you can upload an image, and the goal for the machine will be to detect what's on the picture. For example, here, if we put a picture of a dog, the machine is even more intelligent than that. It will not predict the dog, it will predict the breed of the dog. And so you can select which type of processing units you want to use for that task. And when you run it, then you have your predicted read and the time it took. We also have a benchmarking test. And here we focus on two key metrics, one being latency, which is the time per inference the machine will take. And here you want a smaller number. And we have another metric, which is frame per second. So here you want a bigger number, how many images it can process per second. So here you see those metrics for the CPU. Now we are going to run that again using the NPU. Again, benchmarking takes a little bit of time because we are really measuring things. It takes about 10 seconds in this app. But in the meantime, you can also have a look at the different plots, static ones that we have. And you can see the difference between the different processing units. If we wait just a few more seconds, we should have the results for the NPU. So here we have, we see that it performs much, much better. And so then we can move to object detection, which was the last task we tested on this app. This time it's more complex. We're putting in an image, and instead of classifying just one thing, it's going to really segment the whole image and retrieve all the different objects that it has inside. So we are running it on the NPU directly. It detected all of these in that much time. And again, you can run a benchmark that will go through a similar process as before. And you have the comparison down there with the static plots. Because NPU is such a new technology, there is no real good tool at the moment to retrieve the live information of its usage here. So this is why you only have CPU and GPU, but you always have the static plots, or you can run the task manager at the same time and see how it offloads from the other types of processor units. Finally, we have the resource monitor with plots that are running in live time. So you can go through the different tasks and see how what is running in the background. And you can go back up to 3 minutes in the past if you want to run something on another page and then come back here. So you'll see how it evolves in the time. Again, some static plots for you to have a side-by-side comparison. The final thing we have is a recap of the different processing units in the machine. And we also have an About Us page. It's going to appear in 1 second, where you can connect with us on LinkedIn, and we will share our QR codes at the end of the session if you have any more questions.
So now I will discuss the benchmarking results. So a quick recap of the different processors. We have the CPU, which is very general purpose, is best at sequential processing of tasks. We have GPU and NPU, which are both good at parallel processing. The NPU is more optimized for AI and with reasonable speed, but it's very efficient. A GPU is larger and more uses more energy, but it's very good for high power tasks like model training. And you can see here in our data. So at the top, we have the inference time for our image classification task, and we see clearly that for the NPU and GPU, the amount of time drops a lot. It's doing these matrix multiplications in parallel very, very quickly. And this allows it to process many, many more images per second. So to conclude, our project showcases the capabilities of HP AI PCs through these performance-intensive AI tasks, and it shows the potential of running these AI models on a PC locally. So our app features several tasks. The first one is the chatbot with the Retrieval Augmented Generation. So we actually fed it documents from HP spec sheets and about their products. So feel free to ask you questions about their products. And so the model you choose for this task is very important. A small model is capable of running on the consumer PC, but it's limited in its it has potential for improvement in its intelligence. Large models will need definitely a lot more GPUs and data centers. So the image classification tasks allow us to benchmark CPU, NPU, and GPU. And the object detection, this is a more challenging task that we wanted to the PC to perform. And the resource monitoring page, of course, you can see the workload distribution. So during the project, we encountered issues with software support. A lot of machine learning and LLM inference is still focused on CPU or GPU. And so there's a lot that can be, so there's broader support needed in that area. And so the NPU is very new. It's still a black box for many developers. There needs to be more tooling and debuggers and performance profiling provided. And so there still needs to be a technical case for its use. There needs to be benchmarks on the power savings, the inference speed, and the thermal gains for real-world tasks. And with that, I would like to say thank you to our program manager, Kate, our TA, Sebastian, Fabian from HP, and thank all of you for your attention. Don't forget to connect with us on LinkedIn.